This can be frustrating sometimes. Just saying. So, I'm going to start off today talking about some Roman numerals. And Roman numerals look like this. Here. So Roman numerals look like this. We have one is a small I, two small i's, and three, so on. 4 is written with an I in front and a V at the end, and 5 is just simply a V. And then basically you keep adding ones to the V until you get to 9, and then it's an IV, and then 10 is an X. This chart here, you don't need to memorize it. Don't go home memorizing, wasting your time, my time, everybody's time. I try to make memorization as minimal as possible. If you want to take this into the test, when you have a test, you can bring it in with you, or I can put it up on a board. It's fine with me. There's no need to waste time memorizing this. The thing is, you got to know how to use it. Okay? And Roman numbers kind of go like this. If we have 1, for example, is written as a small I or a large I. 2, again, like that. But when you get up to like numbers like 4, they could do it like this, I guess. That would say 4, okay? But the most common way of doing it is put the line first, which is the 1, in front of the V, which is 5. So how Roman numerals work, we have a larger number, like 5 would be a V, okay? 6 would be a V with a 1 after it. But 4 with the 1 in front and the V next. So what that means is that to get, when you're doing Roman numerals, if you have a number that's smaller in front of a larger number, you subtract. What this means here, if we were to explain it, it's like a 1 in front of the 5, which means now I've got to subtract the 1 from the 5, because that's where the 4 comes from. That's crazy stuff. So what that means has very big implications. So if I have 10 is written as an X. So if I want a 9, I'll put a 1 in front of the X, and that's a 9. Yeah, don't try to make sense out of it. This is how they do it. I never need to use this, by the way. He's watching Super Bowl, right? So you know what year it is? What's Super Bowl Sunday? That's why I never read Roman numerals. I'm just joking. Occasionally you might come across them. Sometimes in the medical field, you may or may not. But it's good to just have a clue how they work, and so you understand what's happening. And that's simply how it goes. The smaller number in front. So we'll go back here for a second and took a larger number. But this is say C and L. So I had L is 50, and C is equal to 100. Okay? Alright? So, if I said CL, that's actually equal to 150, but LC is still also 50. And when I put down, then we know that the 10 is an X. I put down XC, that'll be 90. Subtract the 10 from the 100. So anytime a smaller symbol comes before a larger symbol, you subtract them. So just to make it even more complicated, I wonder what Roman Empire collapsed, right? I had to number math like this. I couldn't never be successful. Who would understand it? So if I did this, XC, that would be, this would be the 90, this would be 4. Oh no. Or again, you can go C into an X, that'll be 110. So the big thing about Roman numerals is watching the order in which the numbers come at you. So if you have a larger one, preceded by a smaller one, you subtract them, and the larger number after a smaller one after a larger number, you just add them together. I know, pretty crazy, but that's the Roman street. But you know what I say, right? When in Rome, waste not my good material, guys. That was pretty funny. I thought that was hard. I'm just joking. You can use my sense of humor eventually, which is no humor.
I thought it was when Rome don't stand behind Julius Caesar.
Yeah, exactly. That would be a bad idea. So let's try a couple of examples of this stuff. M will be 1,000. I had to look it up myself. I don't know either. That's why I don't make you memorize this. Don't memorize it. I'm not going to make you memorize something that I don't memorize. I see these once a year, and that's all I see them every year. So it's not the biggest thing you're going to learn math this year, right? So don't bother memorizing it. This chart here, then that's in your book. You can take it in your text. That's what you. I have actually. It's sweet. I've been to. I've been in numerous parts of Italy, but Rome was pretty amazing. So I've seen the Colosseum, Roman Forum, all those wonderful places. Colosseum, big thing about the Colosseum, I thought it'd be bigger, you know. I watched that show Gladiator with Russell Crowe in it, and it looks so huge. It's not as big as Hollywood makes it look like. So I thought it'd be bigger. But it's so cool about it is that when you go, you've been there, you go in the Colosseum. Their stones are worn down. A number of people are walking up and down the steps every year and for thousands of years, so it's pretty amazing. I've also been to Pompeii, I've been to Pisa, I've been to Venice. I've been a lot around Italy a fair bit. I love Italy. Italy's amazing. I've been to Florence as well, so Italy's great. I love it. This is on page. I don't know. 25. Right. So the first one here, the X with the 3 dots, 3 eyes, what would that number be look like? Anyone? Here's Peter Day, my favorite. 13. Stop doing that. I hate when it does that. I was saying it was a bad day, right? So this one is 13. Next one is going to be what?
15.
Sorry, 15. 15. And the next one would be? 31. LV. Looking back here. The L will be 50. And the V, okay. 55. Next one. 26. Sounds good to me. In Roman numerals, if we write this one Roman numerals, what would it look like? Alright? What would the next one look like in Roman numerals? Perfect. Sounds good. Next one. C is 100.
Yes,
This one's tricky. Why? Because 1/2 is SS. So 1/2 will look like what? And number 11 would be? Or 11 would look like? X and I. Sound good? How are you feeling about that? So you guys seem to have that pretty good. The test questions will be very similar to those kinds of things. So if you got that down, you're doing pretty good. Time. Time. Universal time, military time, is used in a lot of healthcare facilities. The good thing about using the 24-hour clock is the fact that you don't have to worry about AM, PM. Takes care of that for you automatically. So. So, it's not too bad to convert this over. Looks like this regular time looks like this, regular clock. And you see here it's 2 o'clock. So basically, if you're counting around the clock, you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? That would be the regular time. Then it would start over again at 1 in the afternoon, 2, 3, 4, and so on. Military time is the same kind of deal in a sense. It just goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But when it gets to 12, instead of going back to 1, it goes to 13, 14, 15, 16, and that's it. That's all to worry about. So if it's 1600, subtract 12 and turn it back to regular time, it's 4 o'clock, right? See right here, this is 2 o'clock, and that would be 1400. Subtract 12, and it's 1400. Or add 12, subtract 12, back and forth. And that's all to worry about that. So the first one looks like this. 1:31. What would it look like in military time?
1:31.
Awesome. About 3:30. Sorry? Next one. And the next one.
Oh, wait, yeah, 20.
And the next one.
12:55. 00:45. Oh no, camera. So it's 12:45.
That's a tricky one. Next one will be, you guys got this down pretty good. 087117, sorry. How about 5:57 p.m.? Nailed it. Next one. And the last one.
21:25.
Sweet. That nailed it. So I think you guys are going to know how about that. So no more waste more time on that. And that's it for the chapter. Chapter's done. Nailed it. So that's the test was done. Everything we did up to this point. There's a sample test in here. I'm going to try that. You can try that. But next thing we do is going to be fractions. Awesome. Okay, so fractions. Let's have a look at fractions. Anybody remember how to do fractions? No. So basically with fractions, it says in here, we're going to have to talk about the terminology, relationships, finding common denominators, all the fun things like that. Equivalent fractions. We're going to go through all the things this says here, but I'm not going to do it in the same order that the book does it in, because I have my own preferred order to do fractions in. So let's get into fractions.
Elliot?
Yeah.
Sorry, Doc. On my brain space.
Yeah.
All my courses right now, like my biology assignments and calendar stuff. I get that would be like 50 below. I don't know. She said like
Fractions. Fun stuff. So let's look at fractions. Let's jump right into the hard part about fractions. You see the pain in his face already. So let's just have multiplying fractions. That got to be really hard, right? Multiplying fractions. So if I had a fraction like this,
okay.
2/3 times 5/7. How'd that work? In this case, multiply the top by the top and the bottom by the bottom. So basically it looks like this. I would take 2 times 5. 2 times 5 gives me 10. And then I would take 3 times 7. It gives me 21. And I put my line there. 10 over 21. Done. Nailed it. That's it. That's multiplying fractions. As hard as it gets. Take the top numbers, multiply them, and then the bottom ones, multiply them together too. That's it. I get more involved with reducing that a bit later on, but right now I want to keep today's first class of fractions pretty basic, pretty simple, and then move on from there. So that's all there's to it, multiplying. So if multiplying fractions, it has to get hard at some point. So how about we did division of fractions? Division got to be nasty. So division, I had this in the same one. I had 2 over 3. Divided by 5 over 7. Now division, that's gotta be definitely gonna be hard, right? Well, all I gotta do, take the second one here. Flip it upside down. You're like, what? What I mean by that is now take the 2 over 3, flip this one upside down, so that's 7 over 5, and multiply. And we just, for every division, take the second one, take the second one upside down, yep, that's how you multiply. So 2 times 7 gives me 14 over 15. That's division. Basically, like this, upside down. Upside down. So, you may have heard a really big math word called reciprocal. Yeah, one of those words. Exactly. Yeah, that just means flip it over. Alright. I'll keep it simple. Maybe it's because I'm a bit simple or something. I'm not sure why, but anyway. Keep it simple. So, if that's multiplication is easy, and division is flip and multiplying, that's easy. Gotta get hard sometime, right? Well, here comes big bad news. How about adding? Stop doing that. This is a 2, by the way. When we're adding fractions, this is a nice example. And the bottoms are the same. Bottom means denominator. Just so denominator. That's a big word for bottom, okay? And also, it costs a fortune to replace it in your car. You can bring it in and say your denominator's gone. Cost you arm and leg. Don't bring it to the dealer for that, whatever you do. Get some out of the garage. So, in the bottoms, and the bottom is the same. Add the top. That's it. And the bottom stays the same. That was tough. Subtraction works the same way. And the top is a bad word for that too. It's called numerator. They're expensive too, numerators. So numerators and denominators, they go on your car, man. I tell you, you're in this big money right there. So I don't call it a numerator, I just call it the top. I don't call it a denominator, I just say bottom. I can't even spell numerator. So no one cares about it. Alright, so What happens if the bottoms are not the same though? This is where the problem comes in with fractions, when the bottom is not the same. So let's try this. All right, so I have 4 circles here. I want to explain this little more drawn out, and hopefully give you an idea what's going on. Because most people, when they try to say something, when they talk about adding with the bottoms are different, they'll talk about common denominator, all that kind of fun stuff, and right away everybody just kind of goes blank, tunes out, and says, "Oh, I'm done with this, done with this." So what I'm going to do it a little differently. I took that circle and divided it into 2 pieces. Okay? How much of the circle is covered? Out of 2 pieces, 1 piece is colored, right? So 1's colored out of 2 pieces. Okay? All cool? Now divided into 4 pieces. So check this out. What I'm going to do. How many pieces are colored? Well, this time there are 2 pieces that are colored. 2 pieces out of 4 pieces. Alright? Not bad. Let's try this again. This is getting pretty fun. I like to do this all day. Simple and easy. Like taking circles and dividing them. Now, I divide it into 6 pieces. So how many is colored now? 3 out of 6. Right? Okay, this is, I see a pattern developing here. So now, I divide it into 8 pieces. And guess what? How many pieces are colored? 4 out of 8, right? Okay. But in each one of those pictures, you can notice that the first picture right here, this one right here, and that picture there, how much of the circle is actually colored? It's 1/2, right? In the other picture, next picture on the right hand side, how much is actually colored? Still a half, right? In the third picture, it says 3/6, but it's still half colored, right? And the last one is also half colored in, right? So basically, all these numbers here are equal. They all simply mean half the circle's colored, right? How is that useful to us? Let's check this out. I'm going to write this down. Now I'm going to add these together. 3 over 8 plus 1 over 2. First thing you notice that the bottoms are not the same. Hate when that happens. Let's just forget it. That's not class for today. Let's just call it quits. The bottoms are not the same. Let's go home. Well, instead of going home, we have an option here. Up on top of those pictures, we said that 1/2 is the same as 4 over 8. They're all equal. So what do we do? Take this one. Nope, not the part. Take the 1 over 2. Put that over there somewhere. Don't need that right now. Take this one. The same value. Swap it out for 4 over 8. Now we can add them. So what we just did is we used an equivalent fraction. 1 over 2. We already said that 1 over 2 is equal to 4 over 8. So when we're going to add these down here, trying to add 1/2, don't add 1/2. Put that over there. And just add 4 over 8 because the value are exactly the same. Now we add them together. Pretty easy again because we said the bottoms are the same. Add the tops. And the answer is 7 over 8. That's it. That's all I do for adding fractions. The bottoms are the same. You ever cool with that? You ever seen it that way before? I like that way because it's very visual as well, moving things around. Okay, but sometimes you don't have time to be always making circles, coloring circles and things, especially if you're on a test and the time and all those kinds of things, or you just don't want to be bothered doing circles, you're tired of writing down circles. What if you didn't have to do that? You didn't need to do that, or didn't want to do that? What happens then? Well, look at the same question. If I have 3 over 8 plus 1 over 2. Okay, before we get into this discussion, I want to just talk about over here for 1 second. If I had this one here, 4 is equal to 4. That's just pretty simple. Basically, they're the same number. Okay? Anytime they're the same number, you can write them like this. 4 over 4. And 4 goes into 4. Remember it goes into this? We did division already. 4 divides into 4 one time. So, if I had a number like, I don't know, 5, multiplied by 1, that just stays 5, right? But watch what happens now. This is going to look really freaky, really scary, really quick. 5 times 4 over 4. Ocean pain. Still 5, right? No, it's not 5 because 5 times 4 is not 5. Okay, let's take this for a second. And remember, we talked about fractions, multiplying fractions before. Any number also can be written like this. Any number, let's say 4 over 1, is the same as saying 4, right? So now multiplying fractions is easy. I'm going to say 5 is the same as 5 over 1 multiplied by 4 over 4. And we just said multiplying fractions is easy. Top times top, bottom times bottom. You can see it becomes 20 over 4, which is in fact still 5. Because 4 over 4 is 1. Stop, do that again. I don't believe you. Alright? Why do you do to me? Making this crazy. So, you see how that kind of got really crazy really quickly, right? But basically all I'm saying is that 4 over 4 is equal to 1. multiply them by 1. Doesn't change anything. Sounds pretty simple, right? So what's that useful for? Okay, let's take this away. Back to our problem here. So in the problem, wouldn't it be wonderful, instead of drawing circles, wouldn't it be wonderful if I can take that 2 and turn it into an 8? That's magic. You're an 8, not 2 anymore. Dave Copperfield, leave your heart out. Okay, so how do we do that? Well, how about we try this? We just said that multiplying by 4 over 4 doesn't change the value of a number, right? Let's try it out up here. Take that one there, multiply it by 4 over 4. Now the new equation looks like this. Oops. And back here, but look back here for 1 second. We already said that 4 over 8, oops, then 4 over 8 is equal to 1/2. This is using circles. Down here, it's using this piece right here. The value didn't change, still 1/2. 4 over 8 is still 1/2. Didn't change the value because we multiplied by 1. Look over here, multiplying by 1 doesn't change anything. So add them together, and you see we get seven over 8. Cool? Now you can say, did we understand that? Or I'll show you another way to think about it if you want. Okay, I'll show you another way to think about it. If you don't like this, just go la, didn't happen, okay? Alright, so I'm thinking like this. If I have 3 over 8 plus 1/2. Remember I told you, if you don't understand something, don't hesitate to ask. I'll show you how to do it a different way, right? Tons of ways of showing you different things. The 8, remember we did factor trees? Not factor threes, factor trees, remember those? If I do that, it just screws the whole brain up, right? Well, let's look at the 8. 8, this can be written like this, if you want to write it like this. Right? Now you can see, if you look at it this way, you can see what's missing over here. You're missing the 4 over here. Helpful, better or worse. I can stop anytime. So, to get the extra 4 over there, what we got to do? We do this. Multiply by 4 over 4. Now you can see, doing it very slowly, 3 over 4 times 2 plus 4 over 4. See? That's where the 4 comes from. Pretty crazy. The bottoms are the same. Just, once again, 3 over 8 plus 4 over 8 equals 7 over 8. Ta-da! Now we made a common denominator. Now you're thinking, okay, well that's just one number. What about both of them messed up? Let's just try one of those. Something one of those. So let's look at this. That's bad. But all I could do is say, the easiest way to think about this is just say, but like I just said back in the last example, what's missing on the left-hand side over here? What's missing over here? Well, you're missing a 5. The right-hand side, what are you missing? Missing a 3. Now you're going to have 10 over 15. So it's just a matter of what's missing. That's all you can figure out. And if you don't like doing that, you can just do this. Take this number, multiply it by that number, put it there. Take this number, multiply it by that number, and put it there. So you can do it that way too. And then multiply bottoms multiplied together to get this number here. Cool? Once the bottoms are the same, back to just adding the tops. This is all fractions is, no big deal. But you say, gotta get hard at some point for fractions, it's gotta get tough. Then you look over here and say, this is messy looking. The larger number's on the top, not on the bottom. Now I'm done. Game over. Off this bracket. How do you fix that? Math people don't like the large number on top. They hate it. It just annoys them. For some reason, it just makes them really angry. I don't know why. I don't care. It doesn't matter to me. But math people, they don't like it. So they don't see the large number on top. How do you fix it? You use your gazintas. Like always. So all you do is say to yourself, how many times does 15 go into 22? You can say 1. What's left over? So subtracting those two numbers, so you get 7 left over. Now you just converted it from an improper fraction to a mixed number. That's all there is to it. Use your gazintas. Can't be that easy. Just look at the larger number. $13 over 4. That's crazy. And that's mad people talking. Again, using the gazintas. 4 will divide into 13. This is where your calculator comes in handy. 3 times, right? There's 3 4s are 12. So 4 goes into 13 3 times, and 1 left over. There you go. You just convert from an improper fraction to a mixed number. That's it. Just using gazintas. This stuff here in your textbook, when it talks about this stuff, about part to whole number relationships, talks about numerator and denominator and all that stuff. I'm never going to ask you a definition in math, so don't worry about it. And you know, they do the same thing in here in your book. They talk about equivalent fractions. And reducing. All right, let's talk about reducing. Reducing fractions. Back second earlier, a few minutes ago, we just said if you have one number over another number, the value is actually equal to 1, right? And 1 times any number stays, the number doesn't change. No worries. So when it comes to reducing, people get all kind of freaked out. But basically, it's just making a factor tree on top, and a factor tree on the bottom. That's all you got to worry about. So let's just have a look at this one here. Over 15. Let's try reducing that. Well, the bottom two numbers they'll multiply to give you 15 would be 5 and 3, right? Right? Pretty cool. So can either one of these numbers divide into 12? And it sure can, because 12 is 4 times 3. And guess what? You can set over here, same number on top and bottom is equal to 1. This is equal to 1. And you now have 4 over 5. And that's reduced. That's it. I'll do it. And if you don't believe me, we had a calculator right here. And luckily enough, I do. The batteries are working and everything. If I went 12 divided by 15, you can see that it's actually 0.8. And if I went 4 divided by 5, see it's also 0.8. So it's the same value, just written in smaller terms. I'm going to give you guys a few minutes, see if you guys can reduce these. Just take a few seconds, see if you can reduce them. This is where your calculator does not help you very much. Six over 24.
You want quarter?
Yep. Why? Because it looks like this. If I were to break it down like I was saying a minute ago, it looks like this. 1 times 6 over 4 times 6. See that? That's where the whole quarter comes from. Not bad. Next one. Have 1 times 5 over 4 times 5. Again, they're gone. But it also is equal to 5 over 10. You can do the same thing, but that's pretty easy because that's just 1/2. But how about 13 over 39? 1/3, yep. Because it's going to be 1 times 13 over 3 times 13. They're gone. And how about the last one? And that's easy. Not bad. If anybody remembers their math in school, what was the most troublesome thing in fractions that you had the most difficulty with? Anybody remember? We'll cure all the fraction phobia this week for sure, or next week. Everything's coming along fine? You guys are okay so far? No one's screaming in pain and agony yet. That's a good sign. We talked about improper fractions already. Let's take a minute and try some out. (25/3) as a mixed number. Well, how would you do that? Back to using this. If you want to use a calculator, I can show you how to use a calculator to help you with this. I'm going to show you about the calculator trick on your phone. And the sideways becomes a scientific calculator. I don't see it in this one. But what I'm going to show you, if anybody has this button on your calculator, if you have that button on your calculator, you're laughing. That will do fractions for you automatically. Put them in as a fraction, and it will just do the fractions and give you out answers as a fraction. Fraction, mixed number, whatever. So you have to know this button right here. My calculator does not have that button, unfortunately. But some of the Casios, and I think some of the other Texas Instruments ones do have that button. If you have that button on your phone or on your calculator, you're in good shape. I don't know why you use it if you want to use it. How you would put it? You put the whole number in first, and you push the enter button, then the top number, and the enter button, and then the bottom number. That would take it and put it in as a fraction. And it'll convert mixed numbers to fractions, mixed numbers. It'll do all the stuff out for you, just with one button. So if you have that button, you laugh, and if you don't, then you got to do it the hard way. Which is like the way everybody else has to do it. So, getting back to this question here, we have 25 divided by 3. Here's a nice and easy way to use your calculator instead of just fudging around all day. Take your 25, divide it by 3. So you see, that gives you a whole number piece. Alright? What that means is that 3 times the 8 gives you 24. So basically it looks like this. The whole number piece is 8. But then 3 times 8 is 24. We're dealing with 25. What's left over? I subtract 24 from 25. I have 1 left over. 1 over 3. How about the next one? 5 is going to 24 how many times? 4 5s. That gives us 20. Subtract from 24. We have 4 left over. 5. Making sense? How about the next one? 29 divided by 5. 6 5s are 30, so it has to be 5. This is 25, and guess what? There's 4 left over. Oh, good. Pause for a second. The battery's dying. I'm dying. It's a commercial. I'm dying. I'm actually dying here. Hope it doesn't break. That once before, and my stylus went off, rolled off my desk. When it hit the ground, the tip hit and bent it. Now it has a big crook in it, so I had to get a new one.